Okay, in this video I'm going to continue on with exercise 6C of the book Fundamental Applied Mathematics. We're on page number 164 and the question is 5. Now please, before you watch this video, watch my video. I think I'm going to call it Really Big Numbers. And the reason I say that is we're going to be dealing with really big numbers, and if you don't understand how to deal with really big numbers, you most likely are going to get an incorrect answer. So just watch that. It's only a couple of minutes long and it explains how to look at really big numbers. Anyway, so to read the question, it reads, if the mass of the moon is capital M and the mass of the earth is 81 times capital M, a spacecraft of mass small m, which I'm going to put here in the center, travels to the moon. At some point P along the line of the centers of the earth and the moon, the spacecraft experiences zero gravity. This is because of the gravitational pulls of the two planets are equal and opposite at P. If the centers are 400,000 kilometers apart, find how far from the Earth's center is the point P. So the first thing we're going to do is note that the radius of the moon is 1.7 times 10 to the 6 meters and the Earth is 6.4 times 10 to the 6 meters. And we're told from point to point is 400,000 kilometers. So if we have 400,000 kilometers, we add another 3 zeros onto that to turn it into meters. Take away from that 6.4 times 10 to the 6, and then take away from that 1.7 times 10 to the 6. Will give you an answer of 3.9 times 10 to the 8 meters. That is the distance x plus y. So I'm going to get rid of this. X plus y, the distance between the two surfaces of the planets, is 3.9 times 10 to the 8 meters. So as a result, you could say x plus y is equal to, we'll say, 4 times 10 to the 8. So what I'm going to say is that y is equal to 4 times 10 to the 8 minus x. Like so. This way we're only going to be dealing with one variable. Now the next thing we're told is that the forces of gravity on both of those are equal. So let's look at that. So the force, it's going to be for the Earth on the particle is the gravitational constant times the mass of the Earth times the mass of the moon, or the mass of the particle divided by a distance which I'll speak about in a moment, and that's going to be equal to the same force exerted by the moon. So we have the gravitational constant, the mass of the moon, the mass of the particle, and a distance to be squared. The distance between the particle and the Earth's centre is 6.4 times 10 to the 6 plus x meters, and we need to square that, of course, for Newton's law of gravitation, and do something similar here. It's going to be 4 times 10 to the 8 minus x plus 1.7 times 10 to the 6 to be squared. Okay, so now seeing that we have pretty large numbers happening now. Alright, so first of all we can do some cancelling, get rid of the m and this m and get rid of the g. And what we'll be left with as a result of that, if we kind of cross multiply, we'll have on the outside 81, and on the inside here it's going to be 1.5 times 10 to the no, it won't be that. I'm looking at the wrong line in my notes here. I have to do this in longhand. So we're going to have we'll say 4 times 10 to the 8 minus x to be squared, and we're going to have on the other side 6.4 times 10 to the 6th plus x to be squared. Now you might say, hold up a second, you didn't take away 1.7 times 10 to the 6th. And the answer is I did, except this is 100 times bigger, so it's approximately 0 anyway. It's very small. So these are approximately the same. Like I said, look at my video on large numbers if you're not following what I'm doing. So get rid of that because we don't want to confuse the issue. Now let's square out this. Remember, you square the first, square the second, and multiply twice the first by the second. So let's see what we do if we get there when we do that. We're going to get here 81 on the outside times 1.5 times 10 to the 17 minus 7.8 times 10 to the 8 times x plus x squared is equal to is equal to 4 times 10 to the 13 plus 1.2 times 10 to the 7 times x plus x squared. And I forgot to close off that bracket there. So now let's multiply in by our 81, and we're going to get 1.2 times 10 to the 19 minus 6.3 times 10 to the 10 times x plus 81 x squared is equal to 4 times 10 to the 13 plus 1.2 times 10 to the 7 times x plus x squared. Now it's just time to rearrange this, so to put all the x's and the x squareds together. And if you do that, you're going to get 80x squared minus 6.3 times 10 to the 10 times x plus 1.2 times 10 to the 19 is equal to 0. Now, if the numbers you're getting are not the exact same as this, but they're close, that's fine. Pretty much, if you had 6 or 7 times 10 to the 10 here, that would be okay. If you had 1 times 10 to the 19, or 1.5, or whatever, that would be grand. Okay? So the next thing we need to do is solve this equation. So just bear with me now, and just reshape this. So I'm going to rewrite that equation. We had 80x squared minus 6.3 times 10 to the 10 times x minus 1.2, or was actually plus 1.2 times 10 to the 19 is equal to 0. Now of course 10 to the 19 is by far the biggest number here. It's 9 powers of 10 bigger than this number here. So it is a billion times, this number is more than a billion times bigger than this number. Or it's actually just under a billion times bigger. Alright? And it is a couple of billions bigger than this. So let's use the equation minus b plus or minus the square root of b squared minus 4ac over 2a, where a is equal to plus 80, b is equal to negative 6.3 times 10 to the 10, and c is equal to 1.2 times 10 to the 19. So we're going to get the following: 6.3 times 10 to the 10 on the outside, plus or minus the square root of 3.9 times 10 to the 21, our largest number so far, minus 4 times 80 times 1.2 times 10 to the 19. Close off my square root and divide the whole thing by 160. Now we're really getting big numbers. 10 to the 21. That's a whole 1,000 times bigger than 1.2 times 10 to the 19, because we have 3 powers of 0, or 3 powers of 10, excuse me. So let's just solve this. We're going to get 6.3 times 10 to the 10 plus or minus 1.1 times 10 to the 10, all divided by 160. So we're going to get two answers. One is 3.2 times 10 to the 8, and the other one is 4.6 times 10 to the 8. Which one do we know to use? And I'm just going to tell you it's this answer here we use. 3.2 times 10 to the 8. So I'm just going to write this now here. 3.2 times 10 to the 8 meters. Now, I'd like you to bear with me for one moment while I clear this up and I have a look at the answer in the back of the book. And that's equal to x, of course. So, let me just have a quick gander at the back of the book. So, 6C, question 5. So 6C, question 5 says 360,000 kilometers. So the answer we're given at the back of the book is we're given 360,000 kilometers, or that x is equal to 3.6 times 10 to the 8 meters. 3.6 times 10 to the 8 meters. And you might say, hold up a second, we're out by a big number here. And I would say, you're not. So let's just see. Well, they're pretty close, first of all. They're both of the same order of magnitude, as in times 10 to the 8. They're both 3 times 10 to the 8, and it's just this this secondary significant figure here. So I'd just like to show you something to see how far apart these two figures are away from each other. So what you do is the following. You have x minus y over x, and you multiply it by 100. That will give you the percentage difference there is between the two figures. So let's just do what we have here. We have the following: 3.6 times 10 to the 10 times 10 to the 8 minus 3.2 times 10 to the 8 divided by 3.6 times 10 to the 8, multiplied by 100, and let's see what that gives us. So we have 3.6 minus 3.2. That's 0.4. So 0.4 times 10 to the 8 divided by 3.6 times 10 to the 8 multiplied by 100, and we get 11.1%. So 3.2 times 10 to the 8 is 11% away from 3.6 times 10 to the 8. And while that's not great, that's a reasonable figure. So I'm going to say yes to that. Now, if I've made a serious error which clearly I haven't copped, please point it out to me. But I think that analysis is pretty solid. Thanks for watching. Please pass it on to your friends and subscribe to my channel.